Thank you for joining Vaporworks on our next installment of Looking Over the Shoulder, where we talk about various fuel-related technologies and also some helpful hints as well for some of your shop practices. Today we're going to look at a fuel pump, and the subject of today is a Walbro 450 liter per hour pump. This one's also known as the Hellcat pump. Part number is F900000267, the 267 pump. They also have in the same envelope and form factor the 525 liter per hour pump. That's the 285, or the 295 pump, which is 535 liters per hour. Again, same form factor and overall size, so they can be used from that standpoint interchangeably. Now, Walbro is owned by a company called TI Automotive. TI also owns Cooper Industries and a variety of other Tier 1 world-class products. These guys are the best at what they do. If Mopar, Bugatti, Ford, if they're choosing these parts, it's good stuff. So without further ado, let's jump into it, and as we go along, we can talk a little bit more about features, benefits, advantages, and how to make these things live longer. So first, this is the inlet side. So all the fuel comes in through this hole, which is a little under 3/8 in diameter, so fairly small. But fuel gets into this hole by two ways. So the first way, which is one of the best, is inlet head, meaning you want to have a nice high column of fuel to help give this inlet head pressure, so it forces fuel into this inlet. Reason being is that the other way is by suction. So when the pump is spinning on this side and it creates suction, if you can imagine, now the pump is the bottom of the tank, you got a very low fuel level. Let's say the fuel level is only like right here. Now when that turbine is spinning and it's sucking fuel in order to suck it in, it's got to lower the pressure of the fuel. When you lower the pressure of the fuel, you lower its boiling point. Not uncommon at all, especially in modern hot rods. LS swaps, Coyote swaps, anything where you're putting an electric fuel pump in a tank that has lower fuel levels, very common that you get vapor lock. Vapor lock is where the fuel is boiling as it's coming into the inlet. So having a high inlet head pressure and low fuel temperatures helps keep down that chance of vaporization at the inlet of the pump. So this is a turbine wheel. So it's a turbine style pump. Looks kind of like the inlet to a jet engine where the blades are angled, and there's also two rows of them. So TI Automotive has a technology called dual channel, where on the inside you have dual channels. So if you kind of imagine, this turbine wheel sits on here and it spins. When it spins, fuel is coming in. It's being picked up in the channels of the turbine wheel and in the channels here. Now as the fuel moves along these channels, it's being shoved along, it hits the end. Okay? When it hits the end, that's like hitting a wall. Fuel's trying to find someplace else to go because now that's a restriction. So where does it go? It goes to the outlet side of the chamber. And like the inlet side, it has a matching set of channels. As the turbine wheel is spinning, this is the outlet hole is the least restriction, so that's where the fuel is going to go. Now, inside of the motor housing is the armature. This is a 10-pole commutator, 10-pole armature. So there's 10 segments, 2 permanent magnets. So it works on the simple idea of magnetic attraction and repulsion. That's what creates the rotation inside of the motor. So very simple assembly. Slide it together, drop the turbine wheel on, no, end bell side. These are very tight tolerances. tolerances need to be loose enough so that it spins freely, but not so loose that you end up with leaks. If this was a very loose surface, instead of being forced through the holes into the pump, it would just find a way to leak out and go past. So this needs to be a very tight tolerant surface, but not so tight because these are engineered plastics. They don't do well with excessive friction or heat. So that's how that pumping section works. Now to support the armature, there's an end cap. So this end cap just goes on like so. Again, engineered plastic, no rolling element bearings, no brass bushings, nothing like that. Engineered polymers like this can have outstanding performance properties as long as there's sufficient lubrication and cooling. That's where the fuel is so important. Anything or any time when fuel is not available, fuel sloshes away, and this thing is trying to keep itself cool but can't because there's no fuel available, you can see what could happen. You get hot spots on the bearing surfaces and on the commutator, because the commutator, again, is cooled and lubricated by the fuel that's completely surrounding the entire internal side of this pump. So from an assembly standpoint, this now just slides together. So here's your commutator. Here's the end section. So the end section consists of the outlet. So this is the outlet with the check valve. This is the overpressure valve. The overpressure valve is just a simple ball with a spring on it. And if memory serves, I believe this pump is capable of upwards of 115 psi, somewhere around there, before this ball lifts up off of its seat. When it does, fuel goes through that hole, comes up here, and squirts out through that little channel right there. Simple as that. Just a simple ball check valve. The outlet also has a check valve to help maintain line pressure. But that hole diameter where the fuel comes out, so not only is there the restriction from the check valve, that hole is 0.130 in diameter, 1/8 of an inch. So trying to put on a -10 line onto a single pump like this is overkill. 2 450s we've found that can easily be handled by a single -8 line. So as electricity comes through the wires, comes into this section, transferred to the brushes. Now the brushes are typically made out of some type of a graphite material. Brushes transfer the electricity from a stationary object to a rotating object. So pretty simple. This just goes on the end. And the brushes are spring-loaded against the commutator. So for good long pump life, this pump must have fuel to survive. If it doesn't, it will fail. So that's where the OEM fuel modules are the practice for every OEM manufacturer in the world to be able to keep the fuel level high so you get good inlet head pressure and keep the pump very cool. We hope this was helpful. If you have any questions, please feel free to reach out to us at any time and we'll be happy to help. Thank you.